Today's lesson is after compound interest we have the annuity, which are based on compound interest. So what's annuity? Annuity is the sum of money paid on regular payments or withdrawn at regular time. We deal with ordinary annuity, which is payment made at the end of each payment period. In annuities, the payment period must be the same as the compounding period. As we have seen, compounding periods, we have different of them, semi-annually, annually, monthly, quarterly, etc. So let's calculate the future value of annuity, which means that if I regularly deposit some kind of amount, how much will I get after a certain number of years? That's the question for future annuity. For example, let's say if I have $500 deposited every semi-annually at 8% per year, compounded semi-annually, for 10 years. How much money is accumulated? How much money is accumulated? Okay, so the question is, I was depositing $500 every 6 months for 10 years at 8% compounded semi-annually. How much money will I have after 10 years? So it means I'm finding future value. The regular payment is 500, which is R. Then I have 1 plus. I was 0.08, it's semi-annually, I divide by 2 the interest rate. N is number of compounding periods. There were 10 years, so I do 10 times 2 because there are 2 semi-annuals in 1 year. In 10 years we have 20 semi-annuals. Minus 1 divided by I should be divided by 2. Attentively I do the calculation. I can do it step by step because it's not very easy to calculate this. So if I do right calculations, I will have 14,889. So how much interest did I accumulate? Interest will be, how much did I deposit? 500 times 20. Therefore, 14,889 minus the money I deposited, 500 times 20. This will be $4,889. This is extra money I got after 10 years. Okay, so let's see now present value of annuity. Present value of annuity. This is a different formula because what I'm saying here is how much should I deposit, or how much should I deposit now in order to withdraw certain amount of money every month or every year after certain number of years. Okay, so the formula will be present value. Present formula will be R. Then we have 1 minus 1 plus I to the power of minus n divide by I. Divide by I. Okay, so that's the question. Now, so let's see an example of this one here. So let's say how much money should I deposit now in order to get $1,000 every quarterly for 20 years at 6% compounded quarterly. So let's understand the question. The question says, I would like to have $1,000 every 3 months for 20 years. So in order to get that, how much money should I deposit now? Okay, so that means my unknown will be PV. My present value will be PV. Regular deposit means I'm depositing 1,000. I'm withdrawing $1,000. This is regular withdrawal. Regularly, I'm withdrawing $1,000. 1 minus 1 plus 0.06 is quarterly divided by 4 to the power of minus n. Minus n means minus 20 years means 20 times 4. Divide by 0.06 divided by 4. So you have to do the calculation very attentively. So this will give me 46,407. That means I should invest now $46,407 in order to get $1,000 every quarterly. What was the interest, let's say here? What was the interest? The interest paid. The interest, first of all, how much money did I pay? So this is 46,407. How much was I paid? I was paid 10 years every quarter. So in one quarter there are 4. So therefore 20 years. So 20 times 4, that means I was paid 80 times $1,000. Take away 46,407, which means there were 80 payments. I was paid 80 times. 80 times 1,000, 46,407. It means it was 33,593. That means I got a lot of extra money. This is the extra money I got. So these are all about annuities, simple examples about annuities.